We have discussed series and parallel arrangement of resistances. Now we want to discuss uh, special arrangements that involve three resistances. So let's say three resistances, if they are connected to three nodes like this, or let's say like this, then this connection is called Y connection because they look like Y, or T connections. Sometimes they are called T connections, Y or T. And these three, let's say the nodes are these three, I don't know, maybe A, B, C, whatever, A, B, C. Similarly, if three resistances are connected like this, or maybe like this, again the nodes are, let's say, A, B, C here, and this is A, B, C here, then this kind of connection is called delta or pi, because they look like pi. If this one is sort of looking like pi, if we draw it like this, so delta or pi connection. Now what is important, sometimes we need to convert from delta to pi arrangement. So if we have in a circuit, let's say in a delta shape, we want to convert the resistances into a pi arrangement, a Y arrangement, and then we have to change the values of the resistance. How that works, we will show. So we are talking about delta to Y conversion first, and let's say we have a delta connection like this here, or maybe I don't know, maybe like this. So it looks more like pi. So let's say RA here, RB here, RC. Now we want to get the equivalent Y connection. So the equivalent Y will be here, here, and here. So let's say this node is, I don't know, maybe 1. Let's call it R1. Let's call this one 2, this resistance R2, and this node is 3. This could be anything else, this could be XYZ or whatever, so that doesn't matter. So we have, so this is RC, not just C, just to be symmetric, just to be consistent, sorry. So here we have a delta connection, we want to convert it into Y, so we need to find the equivalent Y values. So we want to see what will be the value of R1. So from delta to Y conversion, R1 will be, in the denominator we will add all the three delta resistances, they will be just added, and the numerator will be, let's see that R1 is connected in Y connection to node 1. So in Y connection, only one node is connected to each of the nodes. See, only one resistance is connected to each of the node. Here we have just this resistance, here this, and here this with this node. For delta, each of the node has two resistances. So for A we have this resistance and this resistance. For B we have this resistance and this resistance, so on. So what we can see here, R1 is connected at node 1, for Y will be connected, but for delta there was RB and RC. These two were connected to the same node, node 1. So those two will be multiplied. So RB times RC. That's how the expression will be. Similarly, R2 will be, in the denominator all three will be added. In the numerator will be, since we are talking about R2, that is this node, so the delta resistances that are connected to this node are RC and RA. So we will have RC and RA multiplied. Similarly, R3 will be RA plus RB plus RC, and it will be R, since this is the node where R3 is connected, so RB and RA, these two are connected to this node when it was in delta. So what was that, RB and RA and RB. So this is Y to delta, delta to Y conversion. Now if we talk about y to delta. Let's draw the same one here like that, and again a different color, maybe green, I don't know, like that. So now we have y, we want to get the equivalent delta values. So we have r1 here, r2 here, r3 here, and we have RA here, RB here, RC here, let's say, and this is again our node 1, node 2 here, node 3 here. So now we want to get the value of RA, RB, RC. So RA, when we are doing now Y to delta conversion, so RA will be, in the numerator we will have R1 times R2 plus R2 times R3 plus R3 times R1. This is what we will always have when we are doing delta to Y to delta conversion. And the denominator we will have, since we are talking about we are talking about RA, so we will see that RA is connected to node 2 and node 3. So what is the Y resistance that is not connected to either of these two nodes? So R2 is connected to 2, so R2 is ruled out. R3 is connected to 3, so R3 is ruled out. What is not connected here is R1, so in the denominator will be R1. Similarly RB will be same thing on top, so I won't write it again. R1 times, maybe I will, R1 times R2 plus R2 times R3, R3 times R1. But in the denominator we will have, since RB we are talking about these two nodes, R1 is connected with this node, connected to this node, and R3 is connected to this node. So R2, which is not connected, it is connected to the other node, so R2. And finally RC will be, the top is the same, let's call it delta, if we label it delta, I don't know. And in the denominator we will have RC, so RC is this one, so definitely it has to be R3, which is not connected to either 1 or node 1 or node 2, so that's R3. So these are the conversion formula, and we need to sort of, they're not hard to memorize because there is a symmetry, and if we just remember that we can sort of memorize them. And we often need the conversion while solving circuit, so I will do an example in the next video probably.